Welcome to the second research workshop on the topic of measurement and scaling. In this workshop, we will talk specifically about different types of measurements and scales. So, the different types of measurements and scales that we can use in marketing research and when we conduct market research to investigate some effects on marketing or supply chain related issues are these four different types of measurements. Namely, they're called nominal, ordinal, interval, or ratio, and we use the acronym NOIR to remember these four different types of measurements. And nominal is the lowest level scale, whereas ratio is the highest level scale. This is important later on when we talk about down or upgrading your measurements. So let's take this example here of runners and start with the most basic or lowest level of scale, which would be a nominal scale. A nominal scale is simply used to assign numbers that serve as a label or as a tag. So here in the example that you see on the slide, every runner has a certain number assigned, right? But this number doesn't tell us anything about the runner. It doesn't mean that the runner with the highest number is faster, or it doesn't tell us anything about the age or the speed of the runner. It's simply an identification number that identifies a certain variable in a data set. So that would be a nominal scale. It doesn't tell us anything else, but it gives us an identification or a tag of a number. So similar variables could be, for example, the country of origin. So if you look at different countries, let's say we have the Netherlands, Belgium, and Germany, then these are just tags assigned to a certain variable. They don't tell us anything in terms of a ranking or a hierarchy. We couldn't say that one country is better than the other. Similar here with the example of the runners, the numbers are just really there to serve as a label. The next type of data would be the ordinal scale. And as the name already suggests, ordinal, to put something in order. This ordinal scale allows us to define some sort of hierarchy between different answers in a data set. So they allow to judge for the relative magnitude between answers. So here, imagine the stop clock would have failed and we just observe the runners running over the finishing line. Then we would rank the first runner as first, the second one as second, and so forth. So what we know now is, well, that the first runner comes in first and comes in before the second one. We also know the second one comes in before the third one. So we have some sort of hierarchy established. However, what we don't know is, for example, the speed that each runner ran, the pace, or the time it took them to complete the race. We only get a relative magnitude between the runners. That would be ordinal data. And again, remember, ordinal means you could rank them or put them in order somehow. The third type of data that we have is an interval scale. So the interval scale is a scale that's particularly relevant in marketing and supply chain management research, and you will use it a lot. For interval scales, we assign numbers to indicate absolute differences between a scale point. So for example, imagine we asked all the spectators that you see here on the right-hand side of the slide, how fast do you perceive the runners to be? And they get a questionnaire where 1 means not at all fast and 5 means very fast. And then you can assume that, maybe runner 1 and 2 would both score a 5. They seem to be relatively close together. And maybe all the spectators perceive both of them to be very fast. The third runner will receive a 4 on the scale, and the third runner will receive a 3. The important issue of the interval scale is that the differences between 5 and 4 and 4 and 3 are equal. So this interval scale is used a lot in marketing research, and you will probably also use it a lot in your marketing research process. The last type of scale that we have is a ratio scale. And the difference compared to the interval scale is that we now can assign a true meaning to the 0 point in the data set. So a ratio scale could be, we assign each runner the number of seconds they still have to finish, right? So the first runner has 90 seconds to finish, the second runner still 92 seconds to go, the third one 99, and the last one 106 seconds to go. And these numbers indicate absolute differences between the runners, and they also permit absolute comparison between the runners. It means, so we know that the runner 1 is 2 seconds faster than runner 2. If you think back about interval scaling, then we don't know whether there was an absolute difference between those two runners because they were both rated equally fast. So the important difference between ratio and interval data is also that you can assign a true meaning to the value 0, right? So the lowest value that we get here, time to finish, would be 0, right? It means the runner is just crossing the finishing line. There is no meaning to a minus 10 seconds to finish, right? So think about other types of ratio scales. These are scales that have a true meaning of 0 that cannot be replaced by a different number. If you go back to interval scales, and I'll quickly do that for you, here we decided that we rank people on a scale from 1 to 5, right? We could also rank people on a scale from -2 to +2, right? Which would also be a scale of 5 different points, but we have a value for 0, and we cannot, and this 0 doesn't have a true meaning. It could be also replaced by a scale like we see here on this slide, from a scale from 1 to 5. For the ratio, as I said, 0 has a true meaning. So think about scales like when you want to measure your height, right? The minimum height a person can have is literally 0 centimeters, right? Or think about temperature when it's measured in Fahrenheit. The lowest point you can get is a true 0. So that's important to take into consideration when we talk about ratio scales. How do we identify the different scales that we have in front of us, so nominal, ordinal, interval, or ratio data? We can do that by asking us 3 important questions. So first question that we need to ask ourselves is, do the numbers in front of us mean anything mathematically, or are they just assigned labels or IDs or tags? Because if they're just labels or tags, then we have nominal data. Then our next question would be, is there an equal difference between the different scale points? If yes, we would have interval data. If no, we end up with ordinal data. For example, when we assign different values to different countries, then we cannot say that this data is an interval data, because the differences between countries is not the same. It's an arbitrary difference. So if you rank different countries, for example, you would end up with ordinal data. However, if there is an equal difference between the different scale points, then you either have interval data, or if you also have a true 0, then you would end up with ratio data in your data set. So remembering these 3 questions are really important for your marketing research project. Now, one important question to ask ourselves is, why do we do measurement and scaling, and why does it matter at all, right? So when it comes to measurement and scaling, from a statistical perspective, it is very important because it determines which kind of statistical tests we can run, whether these are non-metric or metric tests. But more fundamentally, the type of scale that we choose determines which kind of statistical measures of central tendency and dispersion we can collect from our data. So if you look at the non-metric side of things, the left-hand side of your slide, then you can see that nominal and ordinal scales do not allow the collection of means or averages and standard deviations in your data set. The nominal scale only allows you to collect the central tendency measure as the mode, and the dispersion would be the frequency distribution. So you could, for example, plot how many males and females you have in your data set. If you collect ordinal data, you can collect a mean and a range. For example, again, if you rank how many runners come in at which position, then you can collect the average rank and the range of runners. However, if you would collect interval or ratio data, which is most powerful in terms of scale design, for both interval and ratio data, you can actually calculate a mean, that means calculating an average, and also a standard deviation, which allows you then later on to run metric statistical analysis. So with this scale, or this slide, it's important to take into consideration that different scales influence the different tests that you have to use later on in your MRP. However, in your MRP, you have to use very different tests. So therefore it is important for your questionnaires later on that you also include different types of scales to ensure that you later on have the opportunity to run all the tests that you need to run to complete your MRP. Another important point, and I'll have an example about that on the next slide, is that you can always downgrade from ratio scale to interval to ordinal to nominal, or you can downgrade from interval to ordinal and so forth, but you can never upgrade scales. And this is particularly relevant because we see a lot of students doing that mistake in collecting some data in the wrong scale and then later on having an issue of not having the correct scale or the correct data available to run their statistical tests. Let me give you an example, and I hopefully have highlighted it clearly on this slide. This is an example that you should not repeat at home, so please don't do that for your MRP. I'll just show you what would happen if you do that. So imagine you want to measure age in a questionnaire. And one way to do that would be to give participants in the questionnaire a multiple choice question like this, and participants can tick in which age group they are, right? So what we have here, we have ordinal data because the numbers assigned are kind of indicators for the relative magnitude between the answers, right? So we know that participants in the age group of, let's say, 55 to 64 are older than participants in the age group of 45 to 54 and so on. So we have ordinal data. The problem with that is we won't be able to estimate the mean of the age in our data set with this ordinal data, right? We cannot upgrade the data to interval or ratio data. From this data that you will receive from this kind of question, you will never be able to identify the age of specific participants, the exact age in years of your participants, right? You always have these groups of age, 18 to 24, 25 to 34, and so forth, but you won't be able to upgrade the data into interval or ratio data. However, what could work is that you collect the data right away in a ratio format, right? So you ask participants, what is your age in years? And you let participants fill out the survey and type in their actual age. So they could be anything like 18 or 25 or 32 or 59, right? And in these questions, you can also indicate that people can only enter numbers. So people don't write out their age, for example, in letters. So that would be a good way to collect the data, because then you end up with a ratio scale. You have full numbers that indicate absolute differences between participants, right? We know that someone who is 40 years old is twice as old as someone who is 20 years old. And it also permits absolute comparison between answers. We have a true meaning for 0, right? No one will be older than 0 years. No one will be younger than 0 years. And we can estimate the mean of the age of all our participants by simply calculating the average of the data set. What it also allows us to do, and that is important, we can recode the age of all the participants into different ordinal categories, right? If you know the specific age for each participant, you can always recode participants into different ordinal categories, which is downgrading from ratio to ordinal data. So if you follow this way of measuring data, you have more flexibility later on in your questionnaires, and therefore it is important to understand that you can never upgrade your scales, but you can always downgrade your scales. Now, so why do we need this for the marketing research project? Why is it at all relevant? So, as mentioned before, the type of data and the type of variables and scales that you use will affect what kind of tests you can use later on. And as shown here in this slide, you always have to differentiate between how is your dependent variable measured and whether you have two independent groups. And for the dependent variable that you see here on the left-hand side, you have three options usually. Either you have non-metric data, such as nominal or ordinal, or you have metric data, or you have two types of metric data if you have two dependent variables. But let's start with the first one, non-metric data. So imagine you measure non-metric data, for example, the gender of your participants, which is male or female. It's non-metric data. And you want to compare something, these two groups to something else. So for example, you want to buy you want to compare if somebody buys clothes online, and you ask it in a simple question from yes to no, and your independent variable is, are you male or female? Okay, so you have two types of non-metric data. You have the males and females, and you have this dependent variable that is also measured in a non-metric format, namely, do you buy clothes online, yes or no? Then you would use a chi-square test for independence. And the chi-square test for independence tells you whether there are different proportions than you would expect in this data set. Right, so then the chi-square for independence will flag significance, and it's used to measure non-metric dependent variables and two different independent groups. Now, what you could also do, you have a look at metric data for your dependent variable, right? Consider the question, how likely are you to order online via express delivery on a Likert scale from 1 to 7? 1 means unlikely, 7 means likely. That's our dependent variable. It's measured on a metric interval scale. And our independent variable is still gender. So we compare males and females, and we compare the different answers of males and females to the question, how likely are you to order online via express delivery? So the independent sample t-test is a test that will tell us whether the differences in the two groups, males and females, for the dependent variable that's measured on a metric scale are significantly different. So in this example, you see that the females have an average of 6.5 and the males of 3.5. And the independent sample t-test will tell us whether the difference between these two means is significant. Now, the independent sample t-test works only for two independent groups, such as males and females. However, if you have more than two independent groups, and it could be 3, 4, 5, up to unlimited, then you cannot use the independent sample t-test anymore, but you will need to use an ANOVA test. So consider the following example. We have the same dependent variable. How likely are you to order online via express delivery on a Likert scale ranked from 1 unlikely to 7 likely. But now our independent variable consists of more than two groups. In this example, 3 different nationalities. So here we see the scores for the Dutch, Belgian, and German responses. And we see the Dutch and the German score 5.5 and the Belgian score 6.5. So we would probably assume that Belgians are more likely to order online via express delivery, and the ANOVA test will actually tell us if the differences between 6.5 and 5.5 are significant. So to sum it up again, you use an ANOVA if you have more than two groups, and you use an independent sample t-test if you have two groups that you want to compare a metric DV on. Then last but not least, we have a bit of a special test, which is a pairs sample t-test. Here you do not have any independent groups, but you measure your dependent variable, which is a metric variable, twice. So usually we do that in a pre and post test comparison, or we do an A and B test on a website. So for example, we could measure how likely are you to order online via CO2 neutral delivery, again ranked from 1 to 7, unlikely to likely. And then we measure that first. Our participants score 3.5. Then we show our participants a video about pollution and CO2 emissions and how each customer that orders online has an effect on global CO2 emissions. And then we ask them the same question again. So we ask them again, and the second time, after they've seen this intervention, this video, how likely are you to order online CO2 neutral delivery? And then we get another average, right? In this case, in this example, after participants have seen the video, they score a 6.5. And the paired sample t-test tells you whether the differences between the pre and post measurement in this example are statistically significant. What you could also do for the paired sample t-test is compare two questions and see which one scores higher. So you could ask your participants once, what is the main reason, or you ask participants for the reasons to order online. And then you ask them again from 1 to 7 to rank several reasons, right? One reason could be convenience, the other reason could be price. And if you want to compare if there's statistical significance between price and convenience, then you could also use a paired sample t-test for that regard. Again, it is important for you to remember when you design your surveys and questionnaires that the measurement scale of your variables influences the type of test that you have to perform. You have to plan carefully and eventually revise your research questions and hypotheses accordingly before you start designing your questionnaire and before you start collecting the data. Because once you have collected the data, there is no going back anymore. You will then need to deal with the data that you have and analyze the data that you have to write your marketing research project.